Hi everyone. Today I would like to show how to create animations of vertical motion. These animations can be very interesting to show dynamically some concepts to your students. The first is the fact that the velocity vector is zero in the highest point. And also, they can be useful to show some abstract things that cannot be seen in experiments of the velocity and acceleration vectors. Before we start, I would like to ask if you think that videos promoting free software should reach more people. Please press the like button, let a comment, and subscribe to our channel. So let's start. So let's start by defining the initial velocity, the gravitational acceleration, and the function that's going to return the position of the particle is going to be given by this here. Let's define the velocity via the derivative of the position, and so that if we change the function of the position, then the velocity is going to change accordingly. Let's determine the time when the particle gets at the highest point, and let's define a variable to get this value there. We have done similarly in the last video, so if you have doubt about this, please take a look there. I will let a card here. And the motion time is going to be twice the time the particle takes to go from the lowest point to the highest point. And before generating the animation, I would like to generate a graph showing the position in function of time. This may be helpful to the students to understand this static representation of the motion. Just a note, I have this message here, but it's not about any error in the code. It's actually that my system is complaining that Maxima interface is set to English, but my system language is Portuguese. So let's continue. If you want to insert this graph in your class notes, then you can save it to a file, so we can make this. Let's set the file name there, and we have to set a terminal. Let's put PNG Cairo there, and this file is going to be saved in the same folder where our worksheet is. So here we have the graph. Let's now generate the animation. So first we have to specify the range in the vertical axis. So the minimum value is going to be 0 and the maximum value is going to be the highest point there. And I'm going to define the number of frames. Roughly speaking, this is actually the number of sub-intervals in which we are dividing the time of the motion. So the number of frames is actually this number plus 1. To generate the animation, let's set the file name and as terminal we have to set animated GIF there, and let's use make list to generate the list of frames, and to each frame we are going to have this option first, Y range, and let's set point type to 7 and point size to 2. And now let's use points to generate the figure of the particle. In the last video, we have shown how to generate animations of the horizontal motion. And we have to insert ordered pairs in points. And the first entry to each ordered pair is going to be the horizontal component of the position, and the second is going to be the vertical component. So in the last video, the first entry was the position of the particle, and the second entry was 0. Since now we are generating animations of the vertical motion, we have the opposite here. First entry is going to be 0, and the second entry is going to be the position of the particle. And we have to tell make list the time interval and the time step between frames. There, if everything is okay, then our animation is in the folder where our worksheet is. So let's see. Our animation looks like this. Let's improve this. First, I would like to remove the ticks of the horizontal axis, since this is a vertical motion. So I can make this using this option there. Let's update here. The second thing I would like to make is to change the aspect ratio so that the vertical dimension is larger than the the horizontal dimension. So I can make this with the option dimensions, and let's set the horizontal dimension smaller than the vertical dimension. Let's update here, and our animation looks like this. Let's insert the velocity vector there, and in order to do this, I'm going to change the X range because the vector head length is related to G size. So let's set X range to this, and let's also set head length to 0.2. And after points, I'm going to insert the velocity vector in green color here. The initial point of the vector is going to be where the particle is, and the second entry here is related to the vector components. And let's divide these components by V0 so that the vector does not appear too long there. Oh, sorry, it's green here. There, let's update here. And our animation looks like this now. We are having the same problem we had in the last video. That's the fact that the vector is not showing entirely in the highest point, and also when the particle is returning to the initial position. To solve this, we have to change the interval in the vertical axis. So to the minimum value here, I'm going to set -1, and I'm going to add 1 to the maximum value. So our animation looks like this now. When we do this, unfortunately, we lose the reference of the ground. And to show to the students that we have negative heights here, we can insert a horizontal line here. So to do this, we can use this option there. So let's see. And now the ground is clear here. Let's insert the acceleration vector, and I may put it in red there. Again, it's going to start where the particle is, and its components are these. And I'm going to divide it by V0 also because I don't want it to appear too long in the animation. Let's update here and see how our animation is now. So our animation looks like this. Other thing that can be interesting is to insert a reference to the highest point so that the students can see very clearly that the velocity vector is 0 in this point. So to insert a horizontal line there, I can use explicit, and I'm going to insert a constant value here, and the variable is going to be x, and the interval of this variable is going to be the same as x range. And now our animation looks like this. There. This code is very interesting because if we change the initial parameters, then both the graph and the animation, they are going to change according with these new values. So for example, let's change the initial velocity to 15 meters per second, and let's execute all cells. When we execute this cell, we are going to update the graph. So the graph is here, so let me put it here and let me update. So we can see that the graph has been updated. And when we run this cell, we are going to update the animation. So the animation has been updated. And we can show both of them side by side to show to the students both representations of the same motion. So this is all I would like to show you today. If you think these animations can be useful in your classes, please press the like button, let a comment, and subscribe to our channel. Thank you for watching, and see you in the next video.